Potence. In a quiet maintenance hangar behind the terminal, where white lights reflect on the matte gray metallic aircraft, young workers move around the aircraft, each with a task, yet all maintaining absolute disciplined rhythm.
No one rushes. No one is overly confident. Because here, certainty is never taken for granted.
The aircraft appears flawless, clean, without visible damage, as if ready for its next flight. Yet that perfection makes them stop longer, inspect deeper, and ask more questions.
Why does something that appears perfect need to be checked again and again? And why, in aviation, doubt becomes a mandatory part of safety.
In normal operation, every aircraft system is designed to function in a stable and predictable way.
Engineers are trained to understand every parameter, every procedure, and every technical limit of each component.
The African-American male engineer monitors system data, compares it with standards, ensuring every value remains within acceptable limits. The female engineer verifies physically that reported data matches what is seen in reality. Workers follow standardized procedures precisely, with no step skipped or altered. Under ideal conditions, if procedures are followed, the aircraft should always be safe and ready.
The system is built with multiple layers of protection and redundancy to eliminate single-point failures.
Checklists exist to ensure no step is forgotten and no detail is overlooked.
All of this creates a sense that the system is nearly impossible to fail.
Yet that very feeling is what they must be most cautious about.
If procedures are strict enough, why do small errors still pass through all layers of inspection?
The male engineer stops at a value that is not abnormal, yet not entirely convincing.
The female engineer rechecks a detail that was already confirmed, simply because it does not feel fully clear.
Ensure the diagnostic sequence is repeated exactly as programmed. Log the confirmation data on your tablets now.
Here, they do not search for obvious errors, but for the possibility that errors might exist.
They do not wait for danger to appear, and they assume it may already be hidden somewhere. Doubt begins to enter every decision, every movement, every glance. And at this moment, a clear contradiction emerges. Why are those who understand the system most the ones who trust it the least? The answer lies in the nature of aviation engineering, where even the smallest mistake can lead to massive consequences.
The male engineer does not see the system as perfect, but as a collection of possible deviations.
The female engineer does not trust the first result, but always verifies from another perspective.
Workers do not act on habit, but question every action they perform. In this environment, confidence is not built on certainty, but on the ability to doubt correctly. They understand that the most dangerous error is not a large one, but a small one that is ignored. Engineering humility begins with accepting that humans can be wrong and systems can also fail.
It forces each individual to confront the possibility that something was missed.
It turns every inspection into a new question rather than a confirmation.
And that creates an invisible yet critical layer of protection for flight safety.
If compared to other fields where confidence is often seen as a sign of competence, aviation moves in the opposite direction. Here, the most skilled are not those who doubt the least, but those who know how to doubt correctly.
The male engineer does not prove his skill by concluding quickly, but by delaying conclusions when necessary.
Workers do not work to finish tasks, but to ensure nothing is left behind. Where every decision is rechecked, not due to lack of ability, but due to understanding the limits of ability.
That is the difference between a system that works well and a system that is truly safe.
Finally, the original question is answered clearly in the way they work every day.
Doubt is not a sign of weakness, but the foundation of safety in aviation.
Engineering humility ensures that no result is ever taken as absolute. It forces them to always look again, check again, and question, even when everything appears perfect. Aircraft are safe not because they have no errors, but because every error is assumed to exist. Those in the hangar do not seek certainty, but the truth behind that certainty.
And this constant process of doubt removes risks before they even appear.
Safety, therefore, does not come from absolute belief, but from controlling uncertainty.
And that humility transforms doubt into one of the most powerful tools to keep the sky safe.